Now today I'm going to start the module 4 of the first topic, which stands for ODE. What do you mean by ODE? Ordinary differential equation. So the module 4 first topic is we need to solve the ordinary differential equation which is having initial values. Now the student will ask, what is the meaning of initial value in the ordinary differential equation? And why we need to solve ordinary differential equation and with Python programming? So now let us understand what is the significance of ordinary differential equation. My dear friend, many practical real model to solve, we need to model it or we need to express it in the form of ordinary differential equation. There are many types of differential equations, but we need only for your syllabus ordinary differential equation. That is the just we need to understand that any problem, real-time problem, we can model in the form of mathematical representation with the help of differential equation. In there, many types are there, but for your syllabus, it is ordinary differential equation. Okay, so now I did not understand still what do you mean by ordinary differential equation? Let us consider I am writing one equation in the form of differential equation which maybe you have studied in your mathematics syllabus. Dy by dx, that is differential equation. So dy by dx is equals to x into y1 plus y0. Right? Now where y1 is initial value, y0 is initial value, and x is the variable. Now this equation is first order. That's all. That's why it is known as ordinary differential equation. That means the order is 1. dy by dx. What is the power? Differential order. It is 1. So dy by dx is equals to x into y1 plus y0, where y1 and y0 is nothing but initial value. Now question comes. Okay, any problem which we have modeled in the form of dy by dx is equals to x into y1 plus y0, where y1 and y0 is initial value problem, which we need to solve. Now, what do you mean by initial value? Initial value means you know that there are the two types of signal. One is causal signal, one is non-causal signal. Causal signal means which will take the input of the present and past. Non-causal signal means it will be the future, right? Now, if you consider the initial value means the value which was there for that problem initially. Let us consider in here, if I will tell you, represent the equation of the student's entry in your class in the form of differential equation. Okay, fine. Now, when I am starting the count, when I'm going to start the count, before that also some value used to be there. That is known as initial value. Initial value means you need from where you have started. What is your reference point to start? Then before the reference point, if any value is there, that is known as initial value problem. Let us consider it's very simple. If someone is playing the chess game and you are playing chess game with your friend. Now what happened? Your friend got some urgent call and he will tell, okay, yeah, you start from here and I will come back again after 1 hour. Now, whatever move your friend has played in the chess, that after that only you need to start. Okay, then the moves what your friend has already played in the chess, it will be initial value because you are not done. You are going to start from that point. So whatever move he has done it, that is the thing about the initial value. And my dear friend, same way in the formulation of mathematics also, from the reference point, before the reference point, whatever the value is there, that is known as initial value. So let us consider y1 and y0 is initial value, some value which is there already, and we have modeled the ordinary differential equation is nothing but dy by dx is equals to x into y1 plus y0. Now here in this equation there are two types of variable. One is dependent variable, one is independent variable. My dear friend, x is independent variable because we are changing the value of x and we are getting dy by dx. But y is depending on x, so it is known as dependent variable. So dy by dx is equals to x into y1 plus y0. I have defined this is known as ordinary differential equation where y1 and y0 is initial value. I have explained what is initial value. Already I have said that x is independent variable and y is dependent variable. So when we are modeling the differential equation in this form, then it is known as equation 2, and where we can write that equation as nothing but dy by dx in the form of matrix. Also we can represent because x into y1 plus y0, so I can write then the matrix 2 matrix multiplication in the form of 0x 1 0 into y0 y1. You will get the same equation. That is the simple way to present it. Now there is in the Python the command is solve IVP. Now solve underscore VIVP. Now what do you mean by IVP? I means initial, V means value, P means problem. That means we can solve with this command solve underscore IVP any ordinary differential equation. And for that it is very simple. What we can do, we will first define the given value. If any given value is there in this problem, if you are going to solve dy by dx is equals to x into y1 plus y0, where y1 and y0 is are initial value, so define these initial values. So here I can define, and then before that first we will import solve IVP from where, from scipy.integrate. So scipy.integrate library function, we will having solve IVP, and we can import that and we can use in our program. Now define the initial values, so we can write y1 0 y0 is some value we can give, and then define the function again. Define the function which you need to solve, give the name of the function. Let us consider I have defined function in terms of x and y, so f of x comma y, and then return the equation. Again you have to need to return the equation which you need to solve. So return x into y1 plus y0, and then you can use the command solve IVP and then function, and give the variation of time, because give the variation of how many intervals you need to do it, and then solve it. So in this way we can solve easily by using the command solve IVP command ODE, ordinary differential equation. And when you are going to solve with mathematics, then it will take some time, but Python will help you in a very small steps. Already I have explained the program. You define the initial values first, because initial values are there, then define the function, name of the function, the return the equation which you need to solve, and then use the command solve IVP, and you will get the answer. Now the question is, maybe you have studied this in mathematics of your third semester syllabus, that there are some rules, methods which we need to follow to solve the ordinary differential equation. Okay, now that method name is RK45, Runge-Kutta 45. Already you have studied it, it is there in your syllabus. But in Python programming, they are using the command solve IVP, but solve IVP is solving the steps of differential equation with the help of RK45. There are the two things. One is RK45, that is the default method of solve IVP. Means even though you are not going to define the method, which method they are going to use to solve ordinary differential equation, that is means the solve IVP, how he is going to solve it, that method, even though you are not defining in the program, automatically or by default it will take RK45. But solve IVP is now the recent one which can be used to solve ordinary differential equation. But before that, earlier it was ODIENT, ordinary differential equation, which we call ODEINT, ODIENT. Now, actually, solve IVP is more popular than ODIENT, so generally we will use solve IVP, and in your syllabus also it is there for to solve with solve IVP, and RK45 is the default method of solve IVP, and which is known as Runge-Kutta 45. Now, in this case, 4 and 5 means total 4 steps it will take, and fifth will be the output steps. So in that case, now the ODIENT is also one method which we can solve it, and we can define ODIENT, and the default method of ODIENT is LSODA. LSODA. So there is nothing but LSODA, and we can write it down in the program also if we want to define that with RK45. So you have to write the same program, but their methods, in that method solve IVP methods, we can write RK45. So in the case of when you wanted to solve with LSODA, then in the methods we need to write LSODA. So here I have explained what is ordinary differential equation and what is initial value problem, how we are going to solve this ordinary differential equation, and what is the default method of solve IVP, that is RK45, Runge-Kutta 45, and ODIENT was the method which we use initially before solve IVP, and that was ODIENT, ordinary differential equation, and the default method of ODIENT was LSODA. Okay, thank you very much.